When we talk about the edge of the universe, it sounds like we're imagining a giant cosmic border, a place where space simply ends, but the real universe doesn't work that way. Instead, the idea of an edge reveals something deeper about how space, time, and light actually behave. The first thing to understand is that the universe has no physical wall, there's no outer shell, no glowing boundary, and no edge you could ever reach. What we call the edge is really a limit created by time, not by space. That limit is known as the observable universe. It's everything we can see, or detect, because light has had enough time to reach us since the Big Bang. Light travels at a finite speed, so we can only observe objects whose light has had 13.8 billion years to get here. But here's the twist, the edge of the observable universe isn't 13.8 billion light-years away, because space has been expanding the whole time. Those distant galaxies are now 46 billion light-years from us. This expansion stretches space itself, pulling everything farther apart. So the edge of the observable universe is a sphere around us with a radius of 46 billion light-years. That doesn't mean we're at the center of the real universe, it just means we're at the center of our visibility, because we can only see from our own position. Imagine standing in a dark fog with a flashlight. You're not the center of the fog, you're just the center of the bubble of light you can shine through it. The observable universe works exactly the same way. As your beam fades into the fog, the rest remains hidden no matter how hard you try to see it. Our cosmic flashlight is simply the speed of light, setting the limits of what the universe lets us observe. Beyond that bubble lies the unobservable universe, regions so far away that their light hasn't had time to reach us yet. Those places exist, but to us, they might as well be hidden behind an invisible cosmic curtain. It's a vast expanse we can infer through physics, but never directly touch, and as the universe keeps expanding, even more regions will slip beyond our reach forever. And here's where things get even stranger, because the universe is expanding faster and faster, thanks to dark energy. Some galaxies are moving away from us faster than light, not through motion, but because space itself is stretching, their light will never reach us. This means the unobservable universe is bigger than anything we can ever detect, even in principle. No telescope, no spacecraft, not even a future civilization millions of years from now will be able to see those regions. They are permanently beyond our cosmic horizon. So does the universe actually have an edge? Probably not. According to current physics, the universe is either infinite or so large that we can't measure its full extent. If it's finite, it doesn't need a boundary, it could wrap around on itself, like the surface of a sphere in higher dimensions. In that case, traveling far enough in one direction could, in theory, bring you back to where you started, without ever hitting a wall. Space would be both finite and unbounded, a concept that sounds impossible until you realize we live inside that kind of geometry every day. So the edge of the universe isn't a place, it's a limit to what we can see, shaped by the speed of light and the expansion of space. The universe itself keeps going, far beyond our horizon, into regions we may never know, but that are still part of the same cosmic story. That's it for today's video. If you enjoyed exploring with me, don't forget to subscribe to Science Lab, where we turn everyday things into scientific discoveries. See you next time.